All right, once again, we have a Module 1 constructed response question that wants you to write a system, but this time it's a system of two linear inequalities as opposed to two linear equations. That just means instead of equal signs, we're going to have a less than or a greater than or a less than or equal to or a greater than or equal to symbol. So it's a system of two linear inequalities. All right? And again, it's going to be super important to pay attention to the fact that x is the number of times each person plays the ring toss, and y is going to be the number of times each person plays the fishing game. So again, like x is not how much it costs to play the ring toss. It's not anything other than the number of times. All right? And that needs to hold true in your inequalities that you write in your system. So it looks like we're going to be writing an inequality for Tom and another one for Sally. So here we go. Tom earns 5 tickets each time he plays the ring toss, and he earns 3 tickets each time he plays the fishing game. So, and he also needs to earn at least 15 tickets total. So keeping in mind all of that, and again, I hope you already, before watching this, if not, pause it and make sure you do this. Make sure you've attempted this, read it all the way through, and attempted it on your own, I guess. But so for Tom, putting all that together, since x is the number of times Tom will play ring toss, and he earns 3 tickets each time he does that, it'll make sense to multiply 3 and x together, or rather 5. I take that back. I'm sorry. He earns 5 tickets each time he plays ring toss. So it would make sense to multiply 5 and x together. So once again, it's 5 tickets each time he plays the ring toss, and he plays the ring toss x number of times, so multiplying 5 and x together would be like all the tickets he would get for all the times he would play the ring toss. And then you would add to that 3y, because he would get 3 tickets each time he plays the fishing game, and he would play the fishing game y number of times. So you would multiply those together, and this right here would be the total number of tickets he would get from all the times he would play the fishing game. And so this is all the tickets Tom earns, and it needs to be at least 15. So that phrase, at least, okay, which obviously is here, at least, as far as mathematics, that translates to a greater than or equal to. All right? So there's Tom's linear inequality. 5x plus 3y is greater than or equal to 15, because we want him to have his tickets can be equal to 15, but they could also be greater than 15. That's what the phrase at least basically means, right? And so now there's Sally. Sally's the one that earns 3 tickets each time she plays ring toss, and 4 tickets each time she plays the fishing game, and she needs to earn more than 12 tickets. So using the same reasoning for Sally's inequality, we would do 3 times x plus 4 times y, because again, for Sally, x and y mean the same thing. X is the number of times she plays ring toss, and y is the number of times she plays the fishing game. So you would do 3 times x and 4 times y and add those together. And hers, because that's total number of tickets again. And her total number of tickets needs to be more than 12. So think to yourself, could she get exactly 12 tickets? To be more than 12. No, it's just going to be that. All right, she needs to be more than 12, which that's going to be strictly greater than. It wouldn't make a lot of sense to have that symbol be greater than or equal to 12, because we don't want to be equal to 12. We want to be only more than 12. And that's part A. And again, like I said in the John video, sometimes you have no chance of even trying part B or part C or whatever until you have part A. So if you were stuck on part A, then you couldn't even have attempted part B. So now that part A is done, pause and attempt part B before watching the rest of the video. So part B talks about what is the least number of times Sally needs to play only the ring toss in order to have enough tickets for the prize she wants. Well, I suppose there's more than one way to think your way through this, but this was what, Sally for the ring toss? So if Sally is only playing the ring toss, that's going to be 3x. So it's like asking, like if she earns 3 tickets each time she plays the ring toss and she needs to earn more than 12 tickets, then we're just kind of thinking about the 3x part of the inequality. And essentially we could just solve this, like divide both sides by 3 to get x by itself. And x being the number of times playing ring toss, so x needs to be greater than 4. And the key here is she needs to play the ring toss more than 4 times, not equal to 4 times. Like, I guess if you were doing this just using common sense or just basic reasoning without actually writing out this inequality, you would at some point along the way think about, well, if she played the ring toss exactly 4 times, she would have exactly 12 tickets, and that's not, reaching her goal. She can't play exactly 4 times and get what she wants. She needs to play a 5th time to get more than 12 tickets rather than at least 12 tickets or whatever. So the answer is actually 5, and I hope you can understand why based on what I just said. Anyway, moving on to part C. Tom decides to play the ring toss only 1 time. After that, he will play the fishing game. What is the least number of times Tom needs to play the fishing game in order to have enough tickets for the prize he wants? Well, Tom's inequality was, I believe, 5x plus 3y, and he needed to be greater than or equal to 15, I think. Let's double check that. 5x plus 3y is greater than or equal to 15. Again, one way to do this fancy is he decides to play the ring toss only 1 time. I mean, that could just literally mean that your x value is 1. X is the number of times he plays ring toss, and we're just saying okay, so it's 1. Now, you personally, if you've already tried this and maybe been successful or almost successful or whatever, that's 5, and just kind of working the baby steps here, solving for y. You end up subtracting 5 from both sides, and you end up here, okay? I guess some of you potentially could have gotten here almost right away in your own head, going well, if he's already played the ring toss 1 time, that means he earned himself 5 tickets, because he earns 5 tickets every time he plays the ring toss, right? Let me just triple check, I guess, about that. 5 tickets each time, yeah. So like again, I guess you could have gotten here like a lot quicker, almost like without any work, you know. And then kind of like, well, I mean, so he earns 3 tickets every time he plays the fishing game, and he only needs 10 more tickets. And so anyway, doing this algebraically here, we end up with y, which is the number of times to play a fishing game, needs to be what, like 10 divided by 3 is like, that's approximately 3.333 or 3 1/3, you know. So the number of times Tom plays the fishing game needs to be greater than or equal to 3 1/3 time. So what would the final answer be? I mean, can we put 3 1/3 here? No, I don't think that really makes much sense. So I think we need to put 4. He needs to play at least 4 times, because he can't play 3 1/3 times, you know. So the next whole number greater than that would be 4.